So, good morning, everyone. Thank you for being here. Buenos días a todos y todas. Gracias por estar aquí. Hoy día vamos a tener la presentación de Hubert Landiger sobre los resultados del estudio de buses, donde analizamos a diferentes alturas en la región de Antofagasta. Y Hubert fue nuestro consultor senior que participó principalmente en el estudio. So, dear Hubert, thank you for being here, and we are very pleased to have you in this webinar. And please, you can start right now sharing your screen.
Yes, thank you very much, Pablo, for this very kind introduction, and welcome also from my side. Thank you for being with us for this webinar. And first of all, I want to say thank you to GIZ for assigning this contract to LBST, and to our partners Belicon for the simulation results, and for ILF Chile for the local contact point. And also thank you very much for the good cooperation during the course of the project. First of all, I want to introduce to you the project team that has prepared this project and the according report. That is at first from LBST side, our managing director, Dr. Uwe Albrecht. That is Reinhold Wurster, senior consultant, also from LBST, and myself, Hubert Landiger, senior project manager at LBST. As I already said, for the simulation activities, we have on board Professor Dr. Ralf Pütz, Managing Director of Belicon, and for the local content and for the local contacts, Fernanda Duran, Business Development Engineer at ILF. Before I start out with the content and the results of the project, I want to say some words about the wording used and the availability of the slides and also the report. So for this report and also for this presentation, we kept the wording with buses. So and also in the meaning of coaches. And of course, the slides will be shared as well. And the report is already available at the about the internet web address mentioned here. For the scope of the work, I want to introduce to you the structure of the work. First of all, the compilation of route-specific characteristics of fuel cell buses, when the compilation of appropriate fuel cell buses available on world markets, and then a compilation of the technical characteristics undermining route conditions. And finally, the recommendations regarding partners for pilot project and a rollout. So first of all, I want to introduce to you the route-specific characteristic. So we have chosen a route from Antofagasta Airport to Minería Escondida and Minería Salvador. And the total route length is about 185 kilometers. The first part from airport to Antofagasta city center, about 25 kilometers, and from there to the mines, 160 kilometers. The minimum altitude is 10 meters above sea level, and the maximum altitude is 3,200 meters. For the maximum gradient, we have chosen two values: 15%. That would be the case for the Minerías Escondida and Salvador. And in order to also have appropriate results for other mining routes, we also have used the value of 18% maximum gradient This is, for example, the case for Minería Candelaria, and we used the 18% for the results of this exercise. So the average gradient that plays just a minor route, 2.5%. The maximum allowed speed is 90 km/h, and the average uphill speed is 50 km/h, and the minimum and maximum temperatures are from minus 20 degrees Celsius to 40 degrees Celsius. On the next slide, we show you the elevation profile from the Antofagasta city center to the Mineras Escondido and Salvida. And you can see that at the beginning there is a less steep increase, and then in the final part of the route there is the steepest increase. In order to create a speed profile, we used this route-specific characteristics and applied the speed limits that are in place on the route. And later on, you will see the speed profile that has been generated out of that. So, and we are already now coming to a part that has been prepared by Belicon, by Ralf Pütz, and that is the route and the vehicle simulation. And as I already said, this uses the data which I already have showed to you. So let's start with the fuel cell operation. So for the stack operation, a temperature of 60 degrees has been assumed. And based on the driving resistances at the drive axle, the route profiles constructed above result in an average hydrogen consumption of about 14.5 kilogram of hydrogen per 100 kilometer for the uphill ride traction at 100% passenger load. That already includes the cooling pump and via compressor consumption. At an efficiency of 50%, the fuel cell generates around 365 kilowatt hours of electrical energy at the drive axle, with this hydrogen consumption corresponding to 2.4 kilowatt hours per kilometer. It has to be mentioned at this point that this is the uphill ride, as I already mentioned. So the average fuel consumption is, of course, much lower. And then it has to be kept in mind that this is not dealing with many stop and go phases. And the energy consumption may increase significantly if the stop and go shares are increasing. So now coming to the overall results, including also HVAC, heating, ventilation, and air conditioning. In addition to traction consumption, energy consumption for heating and ventilation and air conditioning must also be taken into account. That was not the case in the previous results I have just shown you. And here, heating represents the case with the greatest influence. At an ambient temperature of around 21 degrees, the fuel cell and passenger compartment, there is no need to be cooled or heated. But at an ambient temperature of, for example, minus 20 degrees, an average heating power of about 22 kilowatt hours is necessary to keep an adequate ride comfort for the passengers. At 0 degrees, the heating power demand is about 12 kilowatt. In contrast, in warm summers at about 30 degrees, ambient temperature, the cooling power demand merely equals 15 kilowatt. As a result, even with energy management of the HVAC to minimize the consumption, an extra consumption for HVAC may rise to an average of 0.2 kilowatt hours per kilometer, additional to the traction consumption. This equals to an increase in the overall energy consumption of about 10%. And also to be kept in mind, the less the operational speed, the higher the relative share of energy consumption for HVAC. And for urban operation at an average operational speed of about 15 kilometers per hour, heating power is about minus 10 or minus 10 degree may equal traction consumption. So speeding up a little bit, we come to the fuel cell bus manufacturers, which we have tried to contact. And here you can see a list of 16 fuel cell bus manufacturers to whom we tried to get in touch. That is at the very first, Buses for Future. We have received the specification, and you will see some details from them afterwards. They confirmed for publication of their data. For Nalka, it goes the same, also for Photon and for Hyundai, and also for Hyundai. So from King Long, unfortunately, we received no feedback. Lightning e-motors, we contacted them. There was general interest, but no further feedback. And when, for example, Mercedes Evo Bus, they clearly told us that there is currently no interest in this very, very specific market. So they have they are in other markets active, but they told us clearly that for such a specific market there is no interest, and the same goes with New Flyer, Arthur Dennis Limited, and MCI for this group. So and there are some more that show limited interest. For example, Solaris, they focus on Europe. That is what they clearly told us. Toyota Caetano, they sent us a specification. Unfortunately, I have no okay to share it publicly. That is a little bit unfortunate, but I want to mention that. Van Holt told us that they are focusing on Europe and USA. From VDL, we learned that they are offering no hydrogen solutions for the time being. With Wrightbus, we had to sign an NDA to get information, and therefore we cannot share information from Wrightbus. Yutong is focusing on China for the time being, and for Songtong, we did not manage to establish a contact. And now I want to, for those we have received feedback and we are allowed to share that publicly, I want to go briefly through that one by one. I can already let you know it's just a few. And let's start with Buses for Future. So that is a German startup company where fuel cell partner is HiMove from the Netherlands, and they have a prototype already existing, which operates for 2 years now in real-world public transport application. And delivery of 3 fuel cell buses to Münster is scheduled for the last quarter of this year. And they plan to have a production capacity of 40 buses starting 40 buses per year starting from 2022. Here we are talking about type 1 buses, 12-meter buses, low floor, and which are available already and under development are also is also 18-meter bus. I already mentioned the fuel cell partner. The next one might be very interesting for you. It's on the same continent, that is Vanalka. Vanalka is already working on a prototype, and they hope to have this prototype available by June, July next year for performance testing. For the time being, unfortunately, no vehicle is available, and they are preparing vehicles in all bus classes from 1 to 3 as fuel cell vehicles, and their fuel cell partner is Toyota. The next one is Photon from China, and already in 2008, Photon successfully developed the first generation of hydrogen fuel cell buses that served the Beijing Olympics at that time. And in 2014, they produced the second generation of a 12-meter hydrogen fuel cell bus, and they already shipped several hundreds of fuel cell buses to Zhangjiakou for the alpine events of the Beijing Winter Olympic Games 2022. And then Photon developed the third generation, that's a 8.5 meter hydrogen fuel cell bus. And in still within this year, Photon will ship its first 12 meter fuel cell city bus to Australia, equipped with a 700 bar hydrogen storage system. And so fuel cell bus coach types are already available. I already mentioned the 12-meter bus, that is an urban bus or interurban bus, or both are in their portfolio. And they would be, or it's already on their agenda to export these buses to the Chilean market as well. And with regard to the question, are other types of fuel cell buses under development? There was the clear answer: if there is a real demand, Photon would be able to supply those coaches or those buses. Finally, to mention that the fuel cell partner from Photon is Sino High-Tech. Sino High-Tech is the system integrator of Toyota technology, and here you can see again Toyota is very strong, replaced here also in the not only in the passenger car market but also already in the bus market. The next company is Hyundai, also with quite a lot of fuel cell bus experience in South Korea. There are already 112 units of this LX City fuel cell bus on the road since the model has been launched in 2019. And most of you might know that Hyundai is also active in the fuel cell truck segment, and they have already sold commercially to Switzerland 50 of this commercially to Switzerland, and 50 of these trucks will be deployed or have been deployed in 2020. An additional 130 vehicles will be deployed in 2021. And there is a clear goal in 2025. They have a clear goal to put 1,600 trucks into service, not only in Switzerland, but also beyond, in Germany, in Italy. For the time being, tests are ongoing in Italy on the Italian Autobahn for these fuel cell trucks. With regard to the availability of these fuel cell buses, these are 11-meter buses. They can travel 430 kilometers, and Hyundai is already working on a special version with a longer driving range, up to 550 kilometers. That should be available in the second half of next year. And they are preparing that. They already have exports to Saudi Arabia, and trials in Germany are ongoing. Under development, I already mentioned the higher driving range, but in total there are 3 additional models under preparation. That is the Staria 7 to 11 seater, Solati a 15 to 16 seater, and the Universe that is a express in the city bus. And of course, Hyundai has its own fuel cell system. The next one on my list is Hyson. Hyson has already deployed 10 12-meter city buses that have accumulated 250,000 kilometers to date. That is from July. In the meantime, it should be a little bit more already. And Hyson has already developed a 50-seat coach bus, and the first of 10 for the first of them of 10 has already been shipped to Fortescue Metals Group in Australia, and this one already completed 64 days of testing. It's again the dates from July, consisting of more than 15,000 kilometers and loaded to about 19 ton. So Hyson currently offers 40 feet and 60 feet, 12 meter and 80 meter low floor city bus models, and this, which one I already mentioned, the 50-seat coach bus, and those are all available for several global markets. So, and under development are these up to 10 custom-built coach buses for Australia, which I already mentioned. So the parent company of Hyson Motors is Horizon Fuel Cells, and of course, this is the fuel cell partner for Hyson. So that was quite fast, sorry for that, because I want to provide you also with the recommendations we have elaborated in the course of this study. And so afterwards we will have a panel discussion as well. So coming to the recommendations regarding the partners for pilot project and the rollout. First of all, one of our recommendations is to do a study on market potential. Why is that? So the idea is that the initiation of a study on market should be done in order to identify the market potential for this specific type of buses. So this study should come forth with providing market sizes for specific segments. I will come to it in a minute, defined by the specific requirements. Such a study would have the benefit as it would allow the manufacturers to compare their efforts to develop this specific fuel cell bus with the potential turnover they could achieve, of course, taking into account market shares, that's for sure. And the segment definition already constitutes the key specifications for the later fuel cell bus designs. And what's also important to mention is that a compromise needs to be found between the wide range of applications on one hand and over-engineered products on the other hand. So, and I already promised to you that I want to elaborate a little bit on the segmentation of this potential market. And the two most important parameters are the route length and the altitude. And if you have limited route length and the altitude does not play a real important role, these routes can be serviced with battery electric buses. So if you have no other criteria to be taken into account, maybe for short routes, battery electric buses may be the vehicle of choice. But if route length increases, and you will come to limitations, and then It's depending on the route length on the one hand. I put it on the X axis and the altitude on the Y axis, and you can have, well, it's just an example, and it's just to show you the principle. You have segments with medium route lengths and medium altitudes. You have a segment 1, you have a segment 2 with a long route length and a limited altitude, and the same goes with segment 3 and 4, where you have high altitudes and mediate and high route lengths. And if you do such a segmentation, you will see that the number of vehicles that are required from the market, or that what normally is called the market potential, is the figures are different, and also the criteria for the specification for the vehicles are different, and therefore our recommendation is to do such a market study, taking this market segmentation into account. On my next slide, I elaborated a little bit on the required consortium that is required for such a pilot project. And a successful consortium for a pilot project to operate fuel cell buses on mining route should comprise, well, a mining company. It should comprise a mining fleet bus operator. It should comprise a fuel cell bus manufacturer and a hydrogen refueling station manufacturer and an operator of the refueling station and a hydrogen supplier. And if it comes to this hydrogen supply path, of course, all of that can be in one hand, or it can also be split up into these 3 entities, which I just mentioned: manufacturer, refueling station operator, and hydrogen supplier. And in our understanding, if this split up takes place, or if all will be in one hand, has also a little bit to do with the early birds. If the early bird can already cover all 3 topics, it will be in one hand, in their hand. Okay, so on my next slide, I want to elaborate a little bit more on the fuel cell bus manufacturers and what are the advantages of various fuel cell bus manufacturers are, starting with Buses for Future. So this is a really fast reacting startup with a very high commitment to fuel cell technology. So they are fully dedicated to fuel cell drivetrains, and potentially they have access to German funding schemes. That has to be proven, of course, and depends on the project scheme itself. Caetano Toyota. So I already mentioned that Toyota is one of the most advanced manufacturers of fuel cell vehicles on a worldwide basis, with their fuel cell passenger cars that are on sale for many years now. If I remember correctly, so the current Mirai is already the 3rd generation of commercial fuel cell passenger cars. So, and Caetano Toyota manufacturing and sales of zero-emission buses are in the core business of Caetano. That has changed in December 2020, where a company decision at Caetano has taken place, saying, okay, zero-emission buses, and one of zero-emission technologies is, of course, fuel cell technology, is in their core business. The next one of my list is Fanalka. That also shows very high commitment to fuel cell technology and has this regional proximity to Chile. And Vanalka is convinced that the current technology is already appropriate to serve these high altitudes, of course, with some derating, but they are of the opinion that that this can be compensated with batteries. That, of course, still needs to be proven. Further on my list is Photon. So I already mentioned that they are extremely interested in the Chilean market, and they are preparing to offer products to Chile. And they already have a fuel cell coach bus product already available. Also to mention here that this is also not proven for this high altitude. Next one on the list is Hyundai. Hyundai mentioned that they are highly interested in participating in a pilot project, and their fuel cell coach bus model, the Model Universe, is to be introduced into the Korean market next year. And as I already mentioned, fuel cell trucks are already in commercial operation. Finally, there is Hyson. They are fully dedicated to fuel cell drivetrains. They do nothing else, and they have large experiences, especially in heavy-duty fuel cell applications. So they come from another direction, if you want. Not if you compare that to Hyundai or Toyota coming from the passenger car segment. Hyson is coming from the other direction, from heavy-duty applications. And so they also have a fuel cell coach bus product already available. And here goes the same, not yet proven for high altitudes. So initiation of fleet deployments was a question which we tried to answer. That, of course, the fleet deployments depend on the previous activities. Are there already pilot projects? Are there activities? Are there players already there? This is important to keep in mind. When the next one is it sounds easy, but it's not easy at all. This is the hand-in-hand rollout of vehicles and infrastructure in parallel, and this is key. If infrastructure falls behind, the refueling of the vehicles is not safe, cannot be safeguarded. And in the other way around, if the vehicle rollout is too slow, you have an underutilized hydrogen infrastructure, which is then costly, and you cannot gather real-world experience, and your investment is well not really well spent. From the fleet operator's point of view, financial viability of the overall project or the overall fleet deployment has to be assured. So for them, it's the core business. But for the other players, for the other stakeholders, that is important to keep in mind. Being the core business means that they have to spend their daily life out of that, and therefore this has to be, as I said, financial viable. That can be done on its own if the charges to the fleet operators are in an amount that makes this possible. That is, of course, also possible with public support or with industrial cross-financing, filling the gap between their costs and the earnings. So, and finally, to mention is, and that is quite important, even if it's only 4 words here, watch out for synergies, because hydrogen infrastructure is, well, is a costly thing, and the better the utilization and the larger the units are, the higher is, the lower are the costs for that, and therefore synergies with other applications for hydrogen, using the same infrastructure, using potentially the same hydrogen refueling station is very important. And one can say it's also key here, and therefore watch out for synergies in your next steps. I think that's already one of my last slides, maybe the last. So if you want to go fast, and therefore the rocket man on the right hand side, if you want to go for an immediate pilot project, one can select fuel buses already available on the market. One can choose an appropriate but less demanding route that would result and would have the benefits that you can collect numerous lessons learned, and you can collect real-world experiences. And also with regard to the hydrogen supply chain and the infrastructure build-up, that can be of enormous value. And also not to forget about the commercial contacts can be established with such an immediate or early pilot project. And with these words, I want to stop and give back to Rodrigo and say thank you for your attention, and thank you for listening, and hope that you learned quite a lot from my presentation. Thank you.
No, thank you very much, Hubert, for your presentation. Thank you, Pablo, also my colleagues or other colleagues who participate study. I think it was a long and good work, very good work, especially the communication with several manufacturers and the big interest from mining companies and bus operator. And we believe the same, the jointly work with all the stakeholders will be a key element to develop this market in Chile. Okay, now, as I mentioned, we will continue with the conversation panel. And as mentioned also, the Fernanda Stegmaier will be the moderator of this panel. And I invite the guests to turn on the camera. And thank you, Fernanda. And I think, Fernanda, the floor is all yours. And the question will be passed the question to Fernanda internally in order to have all the information from the chat, etc. to Hubert on all the other guests, because I think Corey, it will be a pleasure to answer some questions also, and Alexander Werner also, because he was traveling in Germany and knowing the technology also, and we hoped he tells about the experience. Okay, Fernanda, all yours.
Thanks a lot, Rodrigo, and thank you very much for the invitation. We really appreciate and look forward to continue the work that we've been doing with GATE towards the carbonization of the energy sector, and of course the development of the green hydrogen industry. So thanks a lot, and very welcome also to Hubert. Very good exposition, Corey and Alexander. I'll be first reading the questions we got in the chat, and afterwards I hope we can get to a discussion a bit about the project that Hydrogen is having in Australia, maybe a bit more about the study, and some questions regarding how COPEC is looking to go forward with the results of the study. So first of all, there's a question for Pablo or for Hubert. Have any studies or simulations been carried out for buses at altitudes of 4,000 meters above sea level? Of your knowledge, at least?
Yes, there are a very few out there. So you can find the list of that in the public report. So that can be downloaded from the GZ Chile website, and where you can find, we have in the course of that project, we did some desktop research in this regard. And yes, there are a few studies out there examining exactly that. So on the one hand, this is on road transport, and there are also a topic or an application with comparable situations are applications in the flight sector. So with drones and helicopters and things like that. So they are having the same issues, and therefore some of the studies mentioned there are dealing with that kind of applications.
Maybe just mention it's not for buses, but it's for fuel cells. Those studies that Hubert mentioned. And there is a very detailed analysis or exposition of that in the report, the full report.
Thanks a lot. So also for Paulo, and maybe perhaps also for Alexander, in which context was the study developed, or how come the need of the study?
Yeah, maybe I can start, and then I give the pass to Alex. As Rodrigo mentioned, we have been working together very closely with the Ministry of Energy and also the public authorities, but also our role, as Jay said, is to establish the links between public sector and also the private sector. So in that context, we wanted to support some initiatives from the private sector. And we opened this call for technical assistance last year, and COPEC came with this idea of the analysis of the operation of a fuel cell bus. So, Alex, I think you can complement the rest.
Yeah, thank you for the question, and thank you, Paulo, for the answer. We, of course, as COPEC, we're constantly trying to move forward towards the energy transition, not only regarding hydrogen, but we're covering a lot of energy solutions, thinking about the future, and one of them is, of course, which is today our core business, which is mobility. We're known for our service stations, but the industrial sector is actually our biggest client. And we've, for quite a while now, through COPEC Voltex, our subsidiary company, which is offering electromobility solutions, tackled the battery electric vehicle market. But we also see that there is an opportunity for hydrogen vehicles, especially thinking about longer routes and longer autonomies needed, both for trucks and for buses. And specifically, we've talked to some of our mining clients, and we've seen together with them that some of the routes they will not be able to be electrified, at least with the current status of technology. So that's when we started thinking about a possible pilot. But there was this issue that came to our mind. It was the working at high altitudes. I know that there's a question asking about the troubles in operating in high altitudes that we can get into detail afterwards. And we also wanted to have a better look at all the OEMs that would be able to offer a solution. So that's why we applied to the technical feasibility study that was offering GIZ at the moment. And we, thanks to the GIZ, we were selected and conducted the study together with Hubert.
Fernando, you're
on mute. Yeah.
You're mute.
Thanks. So regarding the last part you were saying, there's actually a question, which are the main effects of the high altitude that can cause over the performance of the fuel cells and the other components? I'm not sure who should take the question.
Corey.
Yes. Sorry, it was a little bit hard to hear. Did you? Do you have one come my way?
Yeah, the question is, which are the main effects that the high altitude can cause over the performance of the fuel cell and the other components?
Yeah. So high altitude is a big challenge for fuel cells. Anything above 2,000 meters, there's a few challenges there. As you know, the air is thinner, right? And so the main principle for a fuel cell is similar to a combustion engine, is you need forced air into the stack to react with the hydrogen and then create electricity. So the air being thinner, it's difficult to get the compression ratio that you need. So therefore, you have to upsize your compressor and have a more powerful compressor. This is possible. There are compressor manufacturers that can meet this standard, but it has to be developed and researched. That's problem number one. Another problem is the heat rejection, because when you have a thinner air, the heat rejection is not as efficient. So your cooling system needs to be taken into consideration. And then there's also the aspect of dryness and less humidity on the input of the fuel cell stack as well. If you can take care of those three factors, then you can greatly prevent the degradation that would come and the power loss from the higher altitudes. So that's one thing that we're looking to work on and develop is handling those three challenges so that we can minimize the power degradation when we get up to altitudes above 2,000 meters and looking all the way up to 4,000 meters.
Great. I think you have the project in Australia. I think you've been already testing one of the 10 buses purchased by Fortescue. Do you know at what altitude are they operating currently?
So right now, because of the COVID situation, all the testing has been done at the National Automotive Test Center in China, and so the altitudes are pretty minimal. And I know for Fortescue, I'm not familiar exactly with the altitude requirement at the mining site there, although I don't think that they are great. So that's one thing to check.
From what I read, it's the max altitude of the max altitude in this test is 3,000 meters above the sea levels, at least in the analyzed route in this test. But I'm not sure about the conditions in Australia.
Right.
But since we're already speaking about that project, which are the challenges that came up while performing or testing the bus in China for the use in Australia?
Sure. So we conducted 15,300 kilometers of tests, loaded at 42,000 pounds. So you can do the conversion to kilograms on that. Sorry, I don't have that ahead.
Kilograms.
In kilograms. We consumed 1,350 kilograms of hydrogen over the 15,300 kilometers. So the test included high-speed freeway running, also analyzing the fuel economy during those situations, air conditioning tests, running with the fuel cell in a stationary position of recharging the batteries, looking at going up in inclines, going down declines, managing the regenerative braking, and also looking at the salt water, the content of the air, and looking at because in the mining sector, we're going to have very fine particles, and that's something that they're working on with the air filters and looking at those test results as well. So the factory acceptance testing with an independent third party is happening now, and so the Australian design rules approval is coming up next, and then so this should be delivered actually any moment now to Australia, and then we should have 9 coaches delivered by the end of the year to Perth. So I think in terms of the lessons learned, we got some durability results out of the fuel cell. So I'm not the exact project manager, so I wouldn't be able to go into great detail about those, but we were generally happy with the conditions of the test and the outcome after going for 15,000 meters. And these are things that we can apply even to some of our other applications.
Great. Really looking forward to have one of those buses piloting here anytime soon.
Yeah.
So there's actually a few questions about that. So the first one for Pablo is, which is the average capex cost of bringing an H2 bus to Chile?
Okay. That is a tough one because there is a very little market, and Hubert knows that Corey as well. I don't know if I am in that position of saying a price, even if I have Hyson here But in some projects, the cost range is between 600,000 and more than 700,000 each bus. But of course, it means that it's a pilot project, and the economy of scale games or play a very big role here.
Right.
And I think it is happening also all around the world. So, but what I can mention, and here I do can mention that, is that Photon wants to be here as well. I hope Hyson as well, and buses manufacturers are selecting very carefully the places where they wanted to develop or starting the market. So and Chile is one of the places that they are watching and having the eyes on it, and that is the first step for any project of this kind. I think that is the most important thing. I don't know if who would want to mention something additional, or Corey.
So when we're looking at Chile as the market to launch more fuel cell coach buses, the standard configuration that we're seeing being applied at the Fortescue site should be fine for altitudes that are moderate and landscape that are moderate. So in the Antofagasta region of Chile and some of the routes near Mejillones, I believe, and the city south of there. So the coach can run basically along the coast, and then we're looking at what we have to do to get it up into the Andes and to some of the mining sites, even as far into the Andes as like Kalawasi or something extremely challenging like that. So we have the solution today for the coast, and we're developing the solution for the higher elevation mining sites.
Just to add one thing, a very nice experience we made in the course of the project was that you already saw the list of fuel cell bus manufacturers we have contacted, and it was quite a long list. And our experience was that so the medium-sized companies that are which are already involved in several pilot project, demonstration projects, early market projects. Many of them declined of getting involved here. Getting involved on the one hand were the small startups that want to. Oh, that's not me.
Fernando.
On the one hand, the small startups that can imagine that as their niche market, and on the other end, the big shots and I would take Hyson here into account, because your target is clearly the world market, and also Hyundai, Toyota, and these big shots. They also show interest in becoming active in Chile. So that's a very interesting experience we could make in the course of the project.
I agree with you. It would be very interesting. So also regarding that, there was another question, and I think it goes to Alex, which is, what will be the main difficulties of bringing H2 bus here to Chile? You've been working a lot with the mining companies. Which is your view and which is their view?
I think the most difficult thing to do is actually to create the consortium that Hubert was mentioning, because right now, I mean, maybe for the high altitude routes, there are still some technical issues that need to be addressed that we already mentioned, right? But it's not that there is no solution for that. I mean, it's just to have a bigger compressor and maybe a bigger fuel cell that has a bit more power to,
right.
Since the compressor takes the power out of the fuel cell as well. So, but it's a problem that can be solved. But I think that the difficulties are not on the technical side, but just to get all the ecosystem and everything right to have a pilot functioning, and that's something we've been working on for quite a while. We know that there are hydrogen refueling stations available from different providers. We would be able to have a hydrogen supply, maybe the vehicles, depending on the timeline, maybe not immediately, but vehicles would be available, but it's just to create the consortium to implement the pilot.
Regarding that, I would like to make the following question up to Corey, because it's a bit of the chicken and the egg problem. What comes first? You make a consortium and then you develop the technology for such conditions, or is it backwards? How was it with the other project, and how you see it going forward? It's a tough question.
Yeah, I think so. So for Australia, we can say that the consortium came first, and then they began to develop in that situation. One of the major developments was the air particulate filter to protect the fuel cell from the mining environment. But otherwise, a lot of the components were proven out and were able to be readily utilized. For Chile, what we're seeing is a few different companies that are excited to take advantage of the renewable resources and the ability to produce renewable hydrogen, and then they're looking for applications that can use this hydrogen. So Hyzon comes in with vehicles in forms of heavy-duty Class 8 trucks and also fuel cell coach buses, and looking to deploy those. When an infrastructure provider or an aspiring renewable hydrogen producer comes to us and has come to us, we're looking at then building out the support network, the consortium that we need, the relationships with, for example, a company that can provide the service for our vehicles, and we're making sure that we have the right actors in place in order to handle the fueling and the deployment and the service and the operation. And then once we feel like those pieces are in place, then that's when now we're looking at, okay, internally and from an engineering standpoint, and we need to, as Alexander said, source these higher power compressors and look at packaging perhaps 2 stacks instead of 1 for get more power to handle these high inclines. And so we're pushing to get the development finished, and now that we see that the demand is there, the support is there, and so that we can move forward as a consortium.
Mm. Or just to add that, I already mentioned that in my recommendations, to start with a less demanding route, that you can use your already existing products, and then you can see, okay, from starting from there, when you have already the infrastructure there, you have the service team there, and all is already established, and then to go into this higher altitude challenge.
Yeah, actually, if you want, Fernanda, I can just show that we have. Did I just take over? I think I took over.
Yes.
This is just very quickly a picture of the fuel cell coach bus that has been running the 15,000 kilometer test. It's a bit ugly because it's a test vehicle. It hasn't been wrapped yet. It has a Hyzon logo on the back, but you can't see it. There's some water vapor coming out of the back here. I promise you that's not combustion engine exhaust. And it's a bit wrapped in the front. So I wish I had something prettier to show you, but this is a real vehicle that we're operating, and so I just wanted to bring that up for everyone.
Pretty cool.
By the way, for engineers, it looks great.
Yeah. The engineers and Fortescue have really appreciated seeing that. I had a video of it driving, but it's a bit grainy. I don't know if it's worth showing, but somebody, yeah. Let's see, we have, watch this. Thank goodness, Teams allows you to do a lot of fun things. So this was, it looked better on my phone when I put it on the computer. It's not as clear, but it just, the fuel cell coach bus going down the road. There's a lot of dirt here from the exhaust and different things. So, and there on the back, you can see barely, it says Hyzon there. So. Yeah, it's real.
The one tested in China, right?
Yep, that's the one. Yeah, that video was taken from.
You're looking forward to manufacture the rest in Australia, or?
Yeah, so there will be sort of a dual approach where we'll do a lot of assembly in China, and we'll do factory acceptance testing with an independent third party, and that's due to COVID travel restrictions between China and Australia. So the first coach bus is actually arriving in Brisbane on Saturday. I just found that note. So that's exciting. And then it will be finalized telematics. They'll do a training program design, and then they're going to calibrate the refueling system. So I think a lot of this will be done out of China, but then sort of like I said, the final. Normally, the factory acceptance testing would be done in Australia because of COVID restrictions being done in China. But yeah, those final elements will be being done in Australia.
Fernanda, maybe I want to add something related to the pilot project or consumption, because I do agree with and we were discussing a lot with Hubert and all the team regarding to if it makes sense to invest a lot of time in the market study for the development of a new bus for high altitude, or we need to start with a pilot project right now. I think in this case the technology is not very well known, so the first steps are very useful to get to sensibilize the people and all the ecosystem more in terms of fuel cell buses, or fuel cell itself and fuel cell buses, of course, and also the delivering or the production of hydrogen. So I was thinking sometimes in some conversations I put the idea, this is a very crazy idea maybe, to have a fuel cell bus operating here in Santiago. For instance, we have a natural park in Cerro San Cristobal, which is right now operating with natural gas buses, I think, and they are going up and down. I think 8 hours. They don't stop these buses, but it will be very useful and as a positive way to having some this kind of pilot project, because you can show to the people. A lot of people is going to the Cerro San Cristobal, which is here in Santiago, for Cory and for Hubert information. It's a very semi-touristic but also a sporting place. And that it will be very nice to have some kind of buses going down, up and down here. Related to the recommendation, of course, there's a lot to do. We are very pleased to support this initiative with Alexander, Cory, or any other manufacturer, and also all the stakeholders. And yes, I think the next step is to have the bus here. So please, Cory, bring us a bus.
Just send me the purchase order and we'll make it happen. 8 months.
8 months. That is important. Maybe you mentioned 8 months, and that is Hubert, that is maybe the standard of the market. We got that response. We need. Once we have the concrete decision, the manufacturer needs 8 or 9 months to deliver it. So yeah,
I think that's mostly current conditions. I would say, with the exception of perhaps some related part shortages due to COVID, we're seeing some supply issues around the world, actually, with some effects from COVID. So that it could push it out. Just to give you a quick anecdotal example, in the United States, there's a demand for medium-duty truck. The diesel truck from Freightliner right now, you can't get it until 2023, and that's a normal diesel truck because of the supply shortages with the chassis and the other components. So so far, I think when I was checking with our colleagues in Australia, we should still be able to do something in 8 months, but that could be actually 8 to 12, depending on supply conditions.
Wow, 3 years.
Yeah. it's incredible, the effects still.
Yeah, but I thought it was only a hydrogen like industry, but if it's to, I thought it happened only to buying mattresses and department stuff, but apparently
not just mattresses, also steel, chassis, chips, other things. These are the effects. But yeah, I think in terms of doing a pilot project, we would love to do a pilot project, and I'd be interested to know, maybe Pablo, if there's any support from the Chilean government just to finance something like that, or provide some incentive to assist a consortium in affording it.
That's a tough question for me, I guess.
Yeah,
we're looking forward to. We're actually like making the numbers for next year, and we're also working with the Ministry of Transport to see if there's feasible to pilot a hydrogen bus that works on the Trans-Santiago route. So we've been working there, and let's see how it goes. But I agree with what Pablo was saying, that it's not only about developing the technology for these specific conditions, but it's also important to bring these hydrogen technologies and applications closer to the population, closer to the industries, and help them become familiar with the management of this new fuel, and create also human capital, because the main problem is not only the altitude, but it's also the willingness to actually operate something that's new for the industry. So I think I agree a lot with what Pablo was saying, and we, at least at the strategy, we look forward to start up with the domestic consumption of hydrogen, and afterwards move forward to the exports of hydrogen, which is not being used in our industry. So. The discussion's been really, really interesting, but I think I'm missing here the technical questions, so I'll move forward to that. The first one would be related to the tank capacity of the buses. They're asking which is the tank capacity of the buses, how many tank capacities you need. I'm not sure if Hubert or maybe Corey could answer that question.
Yeah, I just looked up my spec sheet really quickly. So right now we're looking at this specific vehicle that I showed. The driving range requirement, the autonomy requirement, is pretty short. So we only are carrying 26 kilograms at 350 bar.
But can I want to add something, that not all of the hydrogen in the tanks is usable, right, Corey? There has to be like there are like 3 kilograms that can't be used. So you reach like the 0% tank, and there's still some hydrogen, like 3 kilograms remaining in the tank.
Yeah, I think it might be in this specific example of 26 kilograms. Usually you can utilize around the 90% mark, which is similar to what you said. Yeah, that's true. I will say from personal experience, driving 3 years now, the fuel cell vehicle here in California, that I think I can sometimes get useful closer to 95% of my tank capacity. It's gotten really close. I've run out of hydrogen on purpose a couple times to see how far it can go, and thankfully they provide free towing when you get these vehicles. And when I brought it to the station, I came within just decimals of the tank capacity. I was pretty proud of that. I think it was 5.36 was from a Honda Clarity, and I filled up like 5.29, like something close. Now you have to factor in perhaps an error margin for the counting of the dispenser, but it shows that you can get really, really close. So that's the example of a passenger vehicle. It's slightly different, I think, for the larger vehicle. But yeah, there is some portion that is unusable.
So for example, for 100 kilometers consumption, how many filling points would be necessary? Maybe Hubert, did you include this in the study, or it was one of the questions? Or is it enough with one tank?
No, you will have, if you talk about 350 or 700 bars in the vehicle, what is normally the case, when you have several tanks, and it's a question of how to position the tanks in the vehicle. And if you talk about buses, for city buses, you put them on the rooftop. You have maybe 6, 7, 8 tanks on the top of the roof. If we talk about class 3 buses, you have to spend some part of your luggage compartment to put or you have to sacrifice that. And it's a question how, or it's a trade-off between luggage compartment and driving range, so to say, and you need to
precisely.
Yeah, exactly, and then you need to. It's well, as I said, a trade-off, and then it's a question of the customer in what he puts into his specification. And Corey, please correct me if I'm wrong in saying that, but I think the bus in some limitations, the bus or coach manufacturer is flexible in that. But of course, if you want to service the mining routes, for example, you also require the luggage compartment, and then you need to put the luggage in there, and therefore you cannot be fully use it for the hydrogen tank. So that is a trade-off, as I said.
So exactly that. We're looking at the situation with Fortescue. We only need 300 kilometers range autonomy, and that's plenty for their very, very, very short operation. And I've asked my colleague in Australia, what about 500? And he said it's doable, but you have to sacrifice the luggage. And so how much luggage do you need to carry? That's the question. And so the less luggage, the more hydrogen. I don't know. There's somebody in the chat mentioned 700 bar. If that is possible, you can get some increase. You don't get a full double. You get like 40% or something increase, right? Going 700 bar and 350 bar. That's an option. It creates a little bit more complexity and adds a little bit more cost, which is why we've decided to stick with 350 bar. It adds a bit more cost on the vehicle side and definitely adds more cost on the infrastructure side. So in certain situations where you need to go longer routes, but maybe for the mining employees, I'm not sure. Like you mentioned, luggage is required. I don't know yet exactly how much luggage, and I'd be interested to know, Herbert, what you found in terms of the gear, the equipment that they need to bring with them. It'd be interesting to see if that could be minimized, right, to allow for the maximum amount of space for hydrogen, and then therefore get a bit longer range.
Did you consider that the part of the luggage and the weight in the study, Hubert?
No, we didn't go into that detail because, as I hopefully mentioned, the specification is something that still needs to be done. So we had some kind of a dummy template in order to initiate the discussions. But that was if it comes to real or if you want to receive real offers, the customers need to do a little bit a more elaborate request for offers.
But sorry, Fernanda, but the simulation was done with a full capacity of I think 40 people or 42 persons there in the bus. So this consumption that Hubert mentioned was considering this 14 or 15, almost 15 kilos per 100 kilometers is in the up in the going situation. So when the more demanding and a full capacity considering also the HVAC. So I think simulation is pretty nice to have an extreme condition for the bus. That was the idea. The idea to have the very big consume.
Thank you very much.
Go ahead. Yeah. Sorry.
sorry as well. Thank you, Pablo, for that comment. So the figures which I showed you before, and which you can also find in the report, that is, and please all keep that in mind, that this is not the average consumption of a fuel cell bus from the simulation. It's the very, very worst case. It's the 100% passenger load, and it's for the uphill right traction, including the HVAC. So that's the very, very worst case. But you need to know the limits, of course, and therefore there's a good reason for do the simulation in that case, and therefore this is under extreme conditions, the average consumption will be of course quite lower.
You know, I wanted to mention the same thing, but also just to give an example on how HVAC can affect the consumption. I just had the luck to visit some projects in Germany where they're driving mainly flat routes, and they have an average consumption of 8.5 or 8.7 kilograms per 100 kilometers. But in the winter, when it's really cold, it goes above 11 kilograms per 100 kilometers. So HVAC is definitely something that needs to be taken into account when doing these calculations and simulations.
So unluckily, we're kind of getting to the end of it. So I'm gonna make 2 other questions. I won't manage to make all the questions, but I hope we can get them out. The people who are still here a good view on what are the challenges and to make these things go forward. So the first question would be for Hubert. Is it possible to extrapolate the results of the profile operation to other profiles in the region or to our cases?
I'm not 100% sure if I got the question right. So extrapolating the study results, well, the results are, so we did that, we tried to compile the route specifications for this specific route, and as long as you're within those specifications, when of course it's possible to use them, but as I mentioned already before, it's important that the potential customer puts her specific specifications together and forward it to the bus manufacturers in order to check out if the buses which are in the portfolio of the bus manufacturers comply with the specification. So here goes, well, I would say we are not yet at the stage where we have specifications that can be cover all. So for the time being, we are, as we heard before, we are, or what Corey shows us, we are in a pilot demonstration stage, and therefore the buses or the coaches are still tailor-made, and therefore my recommendation would be, okay, put together your specific route or your route specifications, forward it to the bus manufacturers, and let's see what they are answering.
Okay. Thanks a lot. And one of the last ones would be for Corey. There's a question regarding the relation between the size of the battery and the fuel cell capacity. If it could be smaller or bigger, depending on the needs.
There it is. So absolutely, the fuel cell requirement for I saw some discussion of routes, I think along the coast, maybe from Santiago to Antofagasta. It can definitely be done with a smaller fuel cell. For example, for Fortescue, we're only using 80 kilowatts as the fuel cell inside that bus, with a decent battery pack of 140 kilowatt hours. So it's a bit of a hybrid more than a dominant one way or the other. If you're trying to climb the Andes Mountains with a single fuel cell, whether it's 80, 100, or even 120, you're going to quickly deplete that battery pack, and you basically become a battery dominant vehicle at that point with some help from the fuel cell, because it's a consistent draw. I don't know, Hoover, if you looked at your power requirements, but you need something at least around 200 kilowatts to keep going continuously. It depends on the weight, but or 300. So when you have then two fuel cells and you can get 200 or 220 kilowatts of fuel cell power, then you can really change that into a fuel cell dominant vehicle with battery support, and that allows you tremendous range and tremendous ability for climbing and maintaining climbs and such. So it's definitely more of a super vehicle for mountainous terrain. And the standard vehicle is easier with a single fuel cell for a flat terrain. We're finding the same result with our fuel cell trucks, Class 8 trucks. 120 kilowatts is our standard option, and that's fine for most level terrain, even up to some grades and percentages. You can do even 20% for a short duration, but any long duration inclines and any really mountainous terrain, you're going to have a two fuel cell system, and so there's a bit of customization per application, as Hubert was mentioning.
So really align with what Hubert was saying. It depends on the case, and it's all a bit tailor-made right now. So
yeah, it's all about power demand. Go ahead.
Yeah, it's great because you can get into a variety of routes and needs. So I think
just to add one thing, as Corey already mentioned, the uphill situation where you have the battery quite soon empty. You have the same situation downhill. So you have, after a few kilometers, you have the battery fully loaded, recovering braking energy, and then you just have to carry the battery downwards, and you have the same situation upwards. So it's more a ballast as when as bringing additional benefit into that, and therefore for this specific application where you have a long downhill and uphill situation, the battery will be quite small, but that is of course depending on system design.
And one of the things that we've learned actually from interacting from some actors in Chile is a electronic retarder that actually can then dissipate the electrical energy and apply some braking force once that battery pack is full. Because a lot of the times, I bring back the car example, for my fuel cell car, once my battery is full, it actually tells me on the dashboard, and then from that point you're just using your brake pads. But you can't use brake pads down a mountain on a truck. They'll turn white hot and melt, and you'll have all kinds of problems. So it's interesting looking at the electronic retarder, which also works into like a braking resistor. Those forms of physics.
So unluckily, because it's very interesting, the discussion, I would be happy to stay here for another half hour, but I think Pablo had some closing remarks, and thanks a lot for all the participants here, all the people who met, and all the participants of the panel. I'm really looking forward to have one of those operating here in Chile soon.
Me as well.
Yeah,
all of us.
No, thank you, Fernanda, for the pass. And no, I just want to mention in the chat appears CMPC wanted to have a pilot project. I have to say that one of the companies that worked with us very closely in the study was Verchae. We learned a lot from them. I'm very grateful for them. And so far I know maybe they are operating together. Please be in contact with them. The idea is to create the ecosystem, and maybe the opportunities is there, and we can have this bus soon. In Chile. I think with this, I gave the floor to Rodrigo for the closing, and just to say thank you for all the people here.
Yeah, thank you very much for all, and I would like to thank you again, our guests, for all the information provided in this event. And I think this type of event is necessary to understand not only the technical aspect, but the the business model aspect. Yeah, I think it's very important, and we appreciate your participation to Corey, Alexander, Hubert, of course, Fernanda, Supa, thank you very well. And we hope to hear soon, as Pablo said, about the fuel cell traveling on the roads of Chile. Okay, I will switch to Spanish. And, muchas gracias a todos por su participación. Esperamos verlos pronto. Y nosotros vamos a estar nuevamente con algunos otros temas durante este año todavía, como es inyección en las redes de gas, la parte 2, que podríamos tener otros invitados, y también vamos a hablar de hydrogen carriers, o sea, pensando en la exportación. Y también tenemos contacto con gente que nos va a poder proveer una charla de Canadá, por el tema de hidrógeno en equipos mineros y la experiencia de seguridad. Así que muchas gracias a todos y nos estamos viendo nuevamente. Thank you very much for all.
Thanks, everyone.
Gracias a todos.
Thank you. Bye-bye.